talk about what it is that buildings do that emits carbon. So if I had to break it down into when and how does a building emit carbon, what would that be?
Yeah. So broadly, a well-designed building today, the carbon would be about 50% in the operation, so all of the heating and electricity and so on, and about 50% in the materials. So they're and that's buildings well designed today, and about 30% of the materials carbon is in the construction and the building and the materials supply. So that when you actually put the building up, what we found from our data analysis was that about 20%, so the other bit of the embodied carbon, is in the fit out and the change of buildings over time. So you're tearing things out, particularly in commercial buildings, which are changing quite quickly, and creating another 20% of embodied carbon. And that, to me, is a really good opportunity as a place to start, alongside the harder to deal with, harder to abate items like primary structures being built in concrete. So that broadly, that gives you a sense. This data or this analysis came from a report that we produced, which is also worth looking up, with the World Business Council for Sustainable Development. Where do we stand? And we took embodied carbon. Where do we stand? And we took 5 of our projects and we analysed them to see where the carbon was in the projects. And that was one of the findings. That was quite a lot in the fit out and the churn and the change of a building over time. And one of the other things that was quite interesting, there's quite a lot of carbon in the MEP, the mechanical, electrical and public health. So all of those systems, which are very difficult to identify where the carbon is, and we're still working on that. There's 20% there. So, but the majority of the carbon's still in the structure and the facades, so the basic shell and core of the building.
So there is one component, which is the embodied carbon, which is the material and the construction emissions due to material production and manufacture. The other is to do with operational emissions, which is the energy that a building uses in everyday operations across the life of the building. In many cities, like Singapore, for instance, I don't have a choice of the energy mix of the electrical power that I purchase. It may be dirty or it may be clean. Yeah, I don't have a say. It depends on the state or it depends on energy companies. So what can I do to bring down our operational emissions?
Well, you're always going to start with the more passive things that you can do. So designing a well-insulated facade, providing the right solar shading, and then looking at what passive systems you could employ in terms of natural ventilation and so on, before you actually add any cooling. And then you would look to see, once you've gone through all of those measures, you're obviously going to still have some amount of cooling, heating, some power requirements and so on. You can start to minimise the demand through the efficiency of the systems that you choose. And then once you've reduced that as far as you can then can start to look at what you might generate in terms of renewables on site. That can be quite tricky in a city. You're perhaps much more likely to look at that at neighbourhood scale or city scale, which, as you say, is not so much within your control.
What about embodied carbon? Same problem. I don't I don't have control over supply chains, and many suppliers, particularly in places in the developing world, in Asia, for instance, simply don't offer the data on embodied carbon in a product. So what do I do?
Yeah. So we've got again another hierarchy. So in terms of embodied carbon, if you can be reusing an existing building, and that for some of our clients, for example, that might be actually the way they're using their existing buildings and improving the way they're using existing buildings. So before we even start a project, looking at whether that's a project that's really needed, because obviously I think we're now saying, the most sustainable buildings are the ones we've already built. So can we repurpose and retrofit them? And there's I think the condition in Europe is very much focused on that as a new typology, either change of use or or reuse or upgrading or whatever it might be. And I've for a long time admired the work of Lacaton and Vassal, who now, of course, are very well known, having won the Pritzker Prize
winners.
Exactly, yes. But with a mantra to never demolish, and they've really shown what you can do with existing buildings. So as a starting point, you have to ask yourself, whether you can build less. And then once you've done that, you've really got to make sure that you're building efficiently. So when you come to scheme a project and a building, there's quite a few choices, obviously, that you're making at that point, which then get locked in. So for a long time, the building industry has used concrete flat slab construction. And concrete flat slab construction is easy to build and very easy to coordinate with the rest of the building. It's just a simple flat concrete slab. But it's probably only working at about 30% of its capacity. So what we've understood, and these projects have been built, are still being built actually, but we've started to look at how can we change that. So some simple things, for example, bubble deck is a system, a concrete slab system where you have voids within the slab in the middle where the concrete's not really working. So you're replacing concrete with air. And then the concrete slab doesn't have to carry the load of the concrete that you've replaced. That's a very simple example. But then you can take it a bit further. And if you really could just put the material where it's needed, then a concrete slab that's, say, 30 centimetres thick would become 10 centimetres. That's an example of where by designing efficiently, you can reduce your embodied carbon. And coming back to where is the carbon, a lot of it is in the floor plate of a structure. So if you build a concrete building, in the floor plate, if you can only use the material you need, you can reduce that impact by from down to 30% of what it was. So and so on and so on through the, and then when you get to the end of that, you've done all of those things. You've then got material choices to make, and you could, for example, you could start to look at how you could replace higher carbon intensive materials with lower carbon intensive materials. So timber would be an example of that.
Right.
And in Germany, we've developed with the industry timber concrete composite slabs. So using timber beams and just a 10 centimetre concrete deck. Very good example of that is H7 in Münster with Andreas Heupel, which was one of the early examples of that.
Right.